Okay, so in the last video we introduced point-slope form and we found the slope between our 2 points A and B. So now what I want to go ahead and do is write the equation in point-slope form. And point-slope form is super awesome because if you have a point and a slope, that's all you need, and you can write your equation just like this. So we're going to write our equation, and we're going to leave y as it is. We are going to subtract the y value of our point. Now notice I have 2 points, A and B. It doesn't matter which point you choose, so I'm going to use point A just because it is 2 positive numbers. So I'm going to say y minus the y value of point A, so y minus 3 equals my slope, negative 1/2, times x minus the x value of my point, which is 5. And you are now done writing the equation in point-slope form. Bada boom, bada bing. But what we're saying is you can use either point, so I could also use point B to write the equation y minus 7 equals our slope, negative 1/2, times x minus negative 3 is the same as plus 3. And we are saying these two equations are absolutely equivalent. And this is your point-slope equation of the line that goes through A and B. But let's prove that these actually are equivalent. And I don't mean prove as in like a proof, because I know you guys would cry if I showed you a proof right now. I just want to show that these are the same, and to do that I'm going to convert both of them into slope-intercept form, which is also very useful. So let's take these equations and let's write them in slope-intercept form by solving for y. So I'm going to add 3 on both sides to get y by itself. So we'll get negative 1/2 x minus 5. I'll leave that alone for now, plus 3. And now I need to distribute in and simplify a little more. So that's going to equal negative 1/2 x. And distribute again is just saying multiply each of those. So negative 1/2 x and then negative 1/2 times negative 5 is going to give me a positive 5/2. And then I have plus 3. But again, I want to simplify this. So I'm going to leave the negative 1/2 x alone. Can't do anything to that. But I want to combine 5/2 with 3. So instead of 3, I'm going to write that as, see what I did there? Multiplied by 2 on the top, multiplied by 2 on the bottom. Didn't change anything. 3 times 2 is 6. 6 over 2 is absolutely the same as 3. So I'm going to find that common denominator and then say 5 plus 6 is 11, and that's over 2. And so that is the equation I get for y in slope-intercept form. And let's show you get the same exact thing here, starting with this other equation. So I'm going to do the same thing. I'm going to move the 7 over this time. So y equals negative 1/2 x plus 3 plus 7, because I moved that 7 over by adding 7 to both sides. So I'm going to do like I did before, and I am going to distribute in and then simplify. So I get my negative 1/2 x again, and then I get minus 3/2 plus 7. Just like before, I'm going to find a common denominator. So 7 times 2 is 14. So I have negative 3/2 plus 14/2 is the same as 14/2 minus 3/2. 14 minus 3 is 11. So again, I get the equation y equals negative 1/2 x plus 11 over 2. And it absolutely does not matter which point you use, you end up with the same equations, even though they look different in point-slope form. So we started off by finding finding the slope between 2 points, and then we wrote the equation in point-slope form, and then we took that point-slope form and wrote the equation in slope-intercept form.